So this is the opening menu of VSDL Student Edition, Active VSDL Student Edition. So this is in the file menu. You have to go and click on New. Then there comes this pop-up. Here select workspace. Okay. So let the name of this workspace be first. Okay. You can put your name. Then location of workspace is asked here. By default, it is C:/my design. Then click on OK. Okay. Now here you can create a empty design with design flow. This you can select. You can select any one of these. Okay. Suppose I select this. Create an empty design with design row. Okay. Design flow. Then click on next. Here, the synthesis tools are not installed yet. I have not installed. You can install, then the names will come. But at the beginning or up to end of this subject, we are not bothering with the synthesis. We are going to simulate and test. Okay. So here, block diagram configuration is default HDL language. Language you have to select VSDL. The Verilog is also available, but we have to cover VSDL as per our syllabus. Then click on next. Okay, type the design name. I will type the design name. Suppose I am going to simulate or design half adder. So I will write half adder. Okay, name of the design. Then you can this should be enabled. Do not click this. We need the design directory also. So the name of working library is by default the same as the design name, half adder. Then click on next. Okay. Now here design file path is given. So click on finish. Now you will see some blocks. Okay, these blocks you can see here. This is the workspace we have prepared or they created now. This is the design name half adder. Okay, the workspace is having the same name half adder. You can see here. And here you see some blocks. This is SD, FSM, BD, header descriptor block, then functional simulation block, then a flow setting block, PCB interface block. So we have to deal with this block. Okay, SD block. Click on SD. Now here it will ask for language, either VSDL or Verilog or System C. So we have to select VSDL. Click on OK. Okay, then this source file wizard will come. You can see the source file wizard. Okay. So wizard will create a source file with initial VSDL code using the design. That means by means of this wizard, the whatever default settings are there, library section, entity dictionary section, and the empty architecture body is prepared automatically. We have to give the names particular, okay, of identifiers or entity name. Click on next here. Here it is asking type the name of source file to create. So let the name of first source file is src1. I am giving. You can give any other name. Type the name of the entity. Entity suppose for half adder RHA. Okay. Type the name of the architecture body. Now architecture of entity HA. So I will write arc underscore HA. Now here in while writing this name, you remember one thing. Here between two character space is not allowed. Dash is not allowed. Okay, special characters are not allowed. If you have to separate out the two parts of an identifier, put the underscore or hyphen as I have given. Okay, so that you remember. Otherwise, it will be treated by some other way and there will be semantic errors. So you remember this, then click on next. Now here a block is shown. This is nothing but block diagram of half adder which you have to complete. That means how to complete. This is a block. You have to specify inputs and outputs. Okay, so click on new. Give the name. Suppose this is one input name A. I am giving capital A. Okay, then here name will appear. Now here port direction is selection of port direction is provided here. Now it is input, so I have to click on in. Okay, if it is output, I have to click on out. If sometimes both bidirectional port is there, so in out you can select. Sometimes it is buffer, so you can select buffer. So for this A and B, you have to select in direction, then select click on type. Here port type you have to specify. So this port type, then generally STD logic is given, but here we are going to use 1-bit input. So select this first option, bit type. Okay, click on OK. And then select, now this is the first input A. Input is shown always in the block diagram in left hand side, and the outputs are shown on right hand side. That you know as general knowledge. Okay, so here then B. This is B. Next input type direction is in, type will be same bit type. Okay, then two inputs we have specified. Let us define the two outputs. Let the first output be yes. Okay, you can write some also. I am in short writing yes, capital yes. So it is output, so I have to click this direction out. Okay, then type is bit. Okay, then again next output is there, second output, that is carry, that means I write C. Okay, it is output, so this should be clicked. Then type will be same with type. Okay, now you can see here the block diagram. Here the inputs as I have specified A and B are shown, and the two outputs S and C are shown. The entity name is also given here, HE. Okay, then click on finish. Okay, this wizard is finished. We have declared this our entity. Okay, now after this you will get the template of program, which is with the details we have provided in this wizard. This is library section of the program. Okay, these two lines by default these are there. You can change this or you can add some other clauses. Then there comes entity declaration part. Entity HA is the name of entity I have given, you remember. Then automatically it appears here. Is followed by port. These A, B, S, C are the names as I have given. Okay, this will appear here. So entity declaration part is ready here. Library section is ready. Okay, now let us, third section is architecture body. So let us see what is there in architecture body. So architecture body's first line is ready. Architecture keyword followed by the architecture name. I have given this architecture name, you remember, architecture of entity half adder. So I have written the name ARCH underscore HA. Then of keyword, then HA, that is this entity name, then is keyword. Then there comes begin and at the end architecture. So in between this begin and end, we have to write the things. So for simulating our, we are going to design or represent here the function of half adder. So you know that the function of half adder, that is generates sum and carry. How it generates sum, that can be given by the logical equation yes. Okay, we'll use one the logical equation for that. Yes is assigned. For assigning signal, this symbol is assignment operator is used. C less than followed by equal to. Okay, yes is assigned A space XOR B semicolon. Okay, then C is assigned A and B semicolon. Okay, these two equations are for sum and carry. Now our first this representation of function or behavior of half adder is complete just by adding these two equations. Okay, so we have completed our first program. It is very simple. Then you have to save that program, file save. Okay, then after that, what you have to do? Now our code is ready. Now we have to start simulation. That means first stage is analysis. So for that, we have to go to design, then compile. Click on compile. Okay, if there are syntax or semantic error, this will be shown in the console at the bottom. So I please select this compile. You can see here compile success, 0 error, 0 warning. Okay, you can see this in green letter, this line is shown. Now there is no syntax error. Okay, so what to next? So I have to write, select this simulation menu. This is simulation menu. Click on simulation menu, select initialize simulation. Okay, So initialize simulation means during this process elaboration will be done. So here you can see now these things I have generated now. std.standard, std.text, IEEE standard logic. These all things previously not here, were not here. Now these are provided or they are gathered here. They are collected in this working space. And these are the signal names which are appeared now. Okay, ABS. Now what I have to do? I have to go to select this new waveform box. Okay. So here click on this new waveform. Remember this, which is the icon new waveform just below workspace. Okay, workspace menu, it is at the middle of this new waveform. Click on this. So you will see this space. आपल्या इथं गोंधळ असेल तर माईक म्यूट करा. आलं ना लक्षात? लय लक्षात ठेवा, आपल्या इथं पहिले माईक म्यूट आहे का, म्यूट असला तर चालतं, नाही तर पहिले माईक म्यूट करा. So let us come to point. This is being recorded, so you please consider this. Now signal name is provided here, and here the time scale is given. You can see 400, 800, 1200, etc. So what I have to do? I initialize simulation. Then after that, these clicked on new waveform. Then I will select all these signals or input outputs or terminals A, B, S, C. Okay. Then right click here. Then here this option add to waveform. Fourth option I am going to select add to waveform. These all names will appear here. Okay. A, B are input, S and C are output. So direction is also shown like that. Then here you can see this symbol if you can. Okay. Now what we have to do next? We have to set. Now this is just part of analysis or is over. Elaboration stage is going on now. Okay. We are in elaboration stage. We are arranging the things. Now we are going to specify the input and output. So we have to specify the input type. So right click on this A, signal A or input A. Then this menu will appear. Here select the stimulators option. Click on stimulator. You will see this window of stimulators and the name of the terminal which you have selected. Now what I have to do? I can select a direct value as 0 or 1. I can select one formula, but that is analog formula. I can provide the value input from hotkey, that is from keyboard. That I can provide the value from counter. I can give the random value, but this is bit type of value. By default, it will be either 1 or 0. So the proper signal type for this, we can say logical signals or digital signal is clock type. So it will generate a clock signal. You can set, click on this clock, set the frequency. Here frequency you can change. Suppose this is 10 megahertz for A, I will keep it as 10 megahertz. Then apply, click on apply. Okay, it will be applied. A is clock type input, clock signal. A is a clock signal. Or at input A, we are providing input as clock signal. Its frequency is 10 megahertz. Okay, then close this. Then similarly select another input. Right click here. Okay. Then select stimulator and click on clock. Okay, then here I am going to change the frequency to 12, suppose 12 megahertz. I am changing only value, not in it. Apply. And then here also you will see V is stick and its type is clock type signal. Then click on close. So you have set the values of A and B. Now what we have to do? Now elaboration part is over. Then we have to start the simulation part. So here I will first end the earlier initialize simulation. I will again click on simulation, initialize simulation. This is the first part of simulation stage, initialize simulation. Okay, and after that I have to run the simulation. Now actually this will be execution stage. Okay, or simulation cycle will start. Here you can see the things. Okay, simulation cycle has started. Now it is generating the output. Yet it is not seen. So let us stop this simulation and set timer. Okay, now it has been generated. After stopping, you can see here, now you can see these gray lines or gray bars, but actually these are signals, but these are with very high frequency, so we cannot see them. So for that we have to magnify. So I will magnify using this magnify button. Okay, now it is appearing. So it is now. Now here you can see the time is given. It has, this simulation has started from t is equal to 0 and it is moving forward with 40 millisecond scale. Okay, 40 nanosecond, 80 nanosecond, 120 nanosecond, like this. So initially all values were 0. So for A and B 0 0, S and C are 0 0. Now the values have changed here. A is 0 and B is 1. So if for this situation, that means one of the input is 1, sum will be 1, carry will be 0. Okay, at this time you can see A is 1 and B is 0. So sum is 1, carry will be 0. Now at this instance, if you see at 140 or 60, 160 nanosecond. Okay, so if you click here, you can see I have clicked here and the red line will appear. Okay, so here you can see time is shown 155.86 picosecond. At this instance, value of A is 1, value of B is 1. So accordingly, sum is 0 and carry output is 1. Okay, so by that way, we have tested all the 4 combinations of the half adder. That means of the inputs A and B for half adder, and accordingly, we have got the correct output. So from this waveform, it is seen. Okay, so what you have to do, this is the output of our program. This is the output. These are the input waveforms. First two upper two waveforms are input waveforms. Lower two waveforms are output waveforms. Okay, so this you have to remember.